Hello, everybody. This is going to be a quick demo on predicates, what they are, how to use them, how to write a higher order function that accepts them, how to call the test method on them. And so really quickly, I'm going to hit Control-Shift-T because I'm on Windows. If I type predicate, you can see I just did it a moment ago. But I can sort of investigate this Java util predicate, Java util function predicate, and sort of see the sense of what this is just by these, the top of this interface. First of all, it's a generic interface. It takes it has one type parameter, T. You can pass any class you want. When you create it, you can create it with any class you want. They're going to refer to it as T throughout. It also has this test method, which will accept an instance of T and then returns Booleans. So that's sort of the essence of a predicate, is that it returns true or false. And so there's only one of these non-default implementation abstract methods on predicate, so it's candidate for a lambda. And so what we're going to do is we're going to build a really quick higher order function for predicate, and that takes a predicate, excuse me. So I'm going to make this method, and I'm going to call it E is going to be the generic type that I'm going to use for this method. I'm going to just count up how many items in a particular iterable pass the predicate's test. So I'm going to call that pass count. It's going to take a predicate as a type. Since I've referred to it as E here, I'll use E here, E when I declare the predicate parameters type, not parameter, predicate. Call this method, and I'm going to pass in also some iterable E, and E is for like the elements in the iterable. All of these things are going to have to match up. So any iterable will be accepted. So like list, set, powers of 2 iterable also counts. And so this is going to be our method signature. It's a higher order function because it takes a function as a parameter, is sort of the way to think of it. An interface that has one abstract method is the best we can get to higher order to first class methods or first class functions in Java. So we're going to call this this a function, even though it's an interface which has one and only one abstract method. And so how this is going to work is that I'm going to just keep track of the count. We're going to start off at 0, and I'm going to say for E value in iterable. Just use that for each loop when you can. If, and this is where we're going to call the predicate. It's like if predicates.test method. So whatever the client passes in, right? As long as it passes, right, we'll call test on that predicate and then keep track. Oh, by the way, it worked. Or let's increment that count. And we're all done. Let's return count. Now, if I want to, so that's the definition of pass count. It's kind of a simple higher order function, but you can imagine being able to use it in different contexts. So let's use it in one of them right now. Let's make a list of integers. We'll call it x's. And I'm just going to declare one, I think it's arrays list. Convenient method where I can just start typing in things. So let's just 1, 1, 2, 3, 5, 8, 13, imagine going on and on. Any iterable will do. Let's fill this in with a bunch of integers. I'm going to just really quickly, oh, sorry. We can just hit Control-Shift-F, format everything. It's Command-Shift-F on the Mac. And so now what I want to do is I want to find let's say we want to just find the even count, number of evens in x's, right? So what I can do is call pass count and just say, count how many times this predicate I'm going to pass you right now passes its test. So I'm going to pass x's in. And if I just say return true, that will not be the actual will not be the even count. That'll be the numbers in there, but let's just print that out first. Sys out the even count, and this is really at this moment the total count. Let's give it a try. Oh, it did run. Sorry, I popped it up over there. So you can see it's 10. If I say everybody fails, oh, fails. Sorry, false. Getting a little too crazy here. You can see it's 0. So, we call pass count with this code right here. and it fills in the test method. So Lambda might be a little confusing for people. If you don't feel comfortable with the Lambda, you can always just say new predicate, right? By the way, it's going to predicate of integers. Control space there and invoke content assist. Like Eclipse knows exactly what you want. Like this is a predicate. It has one and only one abstract method. Like I didn't have to type test there in control space. Just simply by saying like, oh, control space on anything. It's like the first thing it offers you is the one method you're missing. And so let's fill this out so it does the correct thing. So right now it's going to be 0. Let's just say for this integer x, return if x mod 2 equals 0, which will tell us if it's even. And now I'm going to get 4. So I get 0, 2, 8, and 34. That's our count for that. And so you can see we have this, perfectly valid predicate. Since I was able to get Eclipse to generate all this code for me, eventually the language agreed with everybody who wanted lambdas to say, all right, we'll do it for you too. And so by simply sort of taking out all of the boilerplate that Eclipse was able to figure out, like there's no ambiguity of what you want when I say new here, this right here accepts a predicate, you must want an anonymous inner class for predicate. Same thing with the test method. Right now I have a terser version of the exact same program. So that's that. To get a little bit, so that's lambdas versus anonymous inner classes. While we're there, let's make, because we made this generic, we don't have to use just integers, we can use any class now. So let's make a list of names, and again, we'll use our friend arrays.asList, which is a convenient way to get lists. I can just like Fred, George, Ron, and Hermione. Now, let's count names with on, right? And so I can say, well, let's find out the pass count, like how many of you passed the following test? And we're going to call it name. I could say string name, but again, there's going to be no ambiguity there. So eventually, if I can say this, just like I could start taking out the anonymous inner class and take out the test method declaration and reduce it to lambda because there was no ambiguity at all. I can also get rid of the type name if I want. Let's leave it in there for a little bit of clarity. So now I've got this lambda. I need to return whether or not I need to return true or false. If I just say return true again, right? I pass names. So that was even count. This is going to be, let's call it names with on count. And if I suss out that names with on, see, there's 4 guys in this list, and that came up with 4. Let's put a few more people in here so we don't come out to the exact same number. Ginny, and we'll put it Harry. Now you can see I passed true, all of them, we now have 8 guys in this list, everybody's doing something. If I say false, that'll give me 0, right, for the number of guys that have passed or have on them. And then if I actually want to build this correctly, I can say name dot contains two for Hermione and Ron. Now these are a little bit pretty simple examples. They're kind of ridiculous, honestly. So let's. I just contacted the registrar's office because I was like, oh, I'm building these filter examples and this MapReduce example. Can you please parse for me? I could have built it myself. I could have done the web scraper, but I decided, like there's this nice public situation in course listings where I can be like, oh, like the spring, can you please tell me all the engineering computer science courses, right? They're sort of all publicly available. I didn't log in. I didn't do 2-step authentication or anything here. Like, you can acquire this. Can you please give me all that data? And so they were very nice. Dr. Murphy in the registrar's office, like somehow handled my request and was like, sent me them back the same day, which is very nice. Thank you. And so, thank you, Dr. Murphy. And so like, what I can do now is I can be like, oh, spring 22, like, give me all the courses, right? And in there is going to be, course has, an ID and a department code and some number of sections and all sorts of other stuff. And so you can imagine, someone at the registrar's office trying to do something where they're like, all right, so how many classes do we have that have multiple sections or have large enrollments? Do we need more classes that for bigger, do we need more classrooms that house bigger courses, stuff like that. So in this situation, I'm just going to do a really quick thing where I'm going to count how many courses have multiple sections. So I'm going to say multiple section count. It's going to count all the courses that have that. So I'm going to call pass count again with a predicate that this time is going to take a course. Of course, and it's going to, we're going to pass in all of these courses. So if I just return true, again, we can find out how many courses there are. There's got to be a little bit, take this data with a little bit of a grain of salt because I'm just parsing these Excel files and trying to get all the data out. If I sys out like multiple section count at this point, which is of course not multiple section count, it's like all courses that are listed in this thing, you see 3,066. And so if instead I'm like, all right, so like how many does this course section size, is that greater than 1? Right? And so now I can see how many courses have a 718 have more than one section. And so somewhat of a, again, still a ridiculous example, but sort of shows off exactly what we're sort of use these higher order functions for. It's like, I want to be able to just pass in any predicate I want. They can be custom all the time. I could filter out different things on courses or strings or integers or whatever I want, and make it generic so it can accept all these different types. But having these higher order functions means that you can very quickly sort of investigate things, and they can be very useful. And we'll have some more demos on this this sort of thing in a minute. Certainly, you're going to build this for your higher order functions exercise, and we're going to have a filter demo next.